Okay, we are in 12.3, and 12.3 deals with dividing polynomials. There's a couple ways you can divide polynomials. Um, if you have a polynomial divided by a monomial like we do in examples A and B, we can just simplify, or if you choose to, you can use long division, which you'll have to do when you divide polynomials exclusively. So what I mean by simplify is like if you take example A, I'm sorry, as 2x cubed plus 6x squared plus 10x is all divided by 2x, which means you can rewrite this as hold on. Oh, had a little glitch on the board. So you can write it as 2x cubed divided by 2x plus 6x squared divided by 2x plus 10x divided by 2x. And if you were to simplify these individually, 2x cubed divided by 2x, well, this cancels, and x cubed divided by x would just be x squared, and 6 divided by 2 is 3, and x squared divided by x is just x, plus these cancel, and then 10 divided by 2 is 5. So that's the answer you'd get if you divide those out. If you did that the same thing for B, you go 6x to the fourth divided by 3x squared minus 12x cubed divided by 3x squared plus 9x squared divided by 3x squared. So simplify this out. 6 divided by 3, I'll put it right here. This equals 2, and then it's x squared minus 12 divided by 3 is 4, and x cubed divided by x squared is just x, plus 9 divided by 3 is 3, and x squared divided by x squared is just 1, so those cancel. So you're left with x squared minus 4x plus 3. So that's one way to solve it. If you have polynomials exclusively, more than likely you're going to have to use long division. Now, long division you've been doing probably since you've been in 4th grade, but here it has a little bit more complexity to it. Plus, if it has a non-zero remainder, it has to be written like in this form. The quotient, which is what you get on top here as an answer, plus the remainder divided by the divisors. So that would be your divisor. Okay. Let's do some examples. So I got x squared plus 2x minus 3 divided by x minus 1. Okay. So let's set it up as a long division problem. So I got x minus 1 all divided by x squared plus 2x minus 3. Okay, so let's look at x minus 1, and then we have our first value inside our dividend is x squared. So what I want to do is I want to find a value up top that's going to cancel out that x squared when you multiply it by x minus 1. So the value will be x, because if you take x and then multiply it by x minus 1, you're going to distribute it out, and it's going to equal x squared minus x. So with that being said, I'm going to write down x squared minus x on the bottom. And just like when we did long division with numbers, you're going to subtract these values. And I'm going to distribute this minus sign to both of these values. So if I put a plus here, I'm going to get a negative x squared, and then I'm going to get a negative here, but because I have a negative minus a negative, so that becomes plus. So x squared minus x cancels out, and 2x plus x ends up being 3x. And just like in long division, we're going to drop down this value, so that's a minus 3. Okay. Now what I need to do is I need to find another value now that's when I use the distributive property, when I multiply by x minus 1, it's going to cancel out that 3x. And the value will be a positive 3. So when I distribute a 3 with x minus 1, I get 3x minus 3. Okay? So I'm going to write that down, 3x minus 3. And again, that gets all subtracted. So if I distribute the negative, so I get a negative 3 here and negative here, but that's double negative, so that becomes positive. So 3x minus 3x, that cancels, and negative 3 plus 3, that ends up being 0. So my remainder here is 0. So my answer for x squared plus 2x minus 3 is x. Or I'm sorry, x squared plus 2x minus 3 divided by x minus 1. The answer is x plus 3. Okay. There are some other keys that you have to keep in mind when dividing by polynomials. First of which is you must rewrite all, both divisors and dividends, all the polynomials in standard form. What that means is you're looking for terms that have variables first. We're going to write the variables before the ones that do not have variables. And the exponents, which ones have the largest exponents, are up in front. So if the largest exponent there was, like, say, x cubed, that one would be shown up first. Second thing you have to keep in mind is you must insert missing terms with 0 as a coefficient. So I'll show some examples of these, and hopefully you'll get a better understanding of those two keys. Okay. So let's look at B. B has, it is 3x squared plus 17x plus 13 is divided by 3x plus 2. So looking at our keys, everything is in order in standard form with both the dividend and divisor, and I have no missing coefficients. So I can just rewrite this as 3x plus 2 divided by 3x squared plus 17x plus 13. Okay, so now since I got 3x plus 2, that means I have to start on this, right next to the 17, somewhere in here. So now I have to find a value that is going to cancel out that 3x squared in there, and that value happens to be x. Because if I distribute the x out to 3x plus 2, I get 3x squared plus 2x. And that gets subtracted, both terms. So if I distribute that negative to both of these, it'll be a minus 3x squared and a minus 2x. So 3x squared minus 3x squared, it gets canceled. And 17x minus 2x gives me a 15x. Now I must drop down my 13, so I get plus 13. And now I am looking for a value that will cancel out my 15x, and that happens to be a plus 5. because if I distribute 5 times the quantity 3x plus 2, that'll give me 15x plus 10. And again, I subtract that whole term, and if I distribute the negative sign, I get negative 15 and a negative 10. So 15x minus 15x is 0, and excuse me, 13 minus 10 is 3. So now I have a remainder. So if I go back up to where we talked about remainder, it's the quotient plus the remainder divided by the divisor. So that being said, so the quotient is x plus 5 plus the remainder, which is 3, divided by the divisor, which is 3x plus 2. Okay. Let's look at C. I have 13 plus 4m squared divided by negative 1 plus 2m. So here is where we have to look at our keys. So I have to now rewrite both divisor and the dividend polynomials in standard form with descending exponents. So with this one, it's going to be rewritten as 2m minus 1, because that is with the x, I have to have the variable in front, and I'm going to divide it by, say I have 13 plus 4m squared, so I got the exponent, so I got 4m squared in front, but I'm missing my m to the first power. So with that, I have to insert terms with 0 coefficients. So it's going to be a plus 0m and then plus 13. Okay? So let's try to solve this one. So I need to find a value that'll cancel out my 4m squared. That will be 2m. So if I were to distribute that out, it'll be 4m squared minus 2m. And that whole thing gets subtracted. So if I distribute the negative, I have a negative here and I have a negative here, but because I got two negatives, that makes it positive, so that cancels, and this drops down to be 2m. Drop this down, I got plus 13, and value that'll cancel out my 2m, that'll just be a plus 1. So if I go plus 1, that's 2m minus 1. Again, it's negative, so distribute the negative, so I have negative here, but that becomes plus. So that cancels, and then this becomes 14. So all I'm doing now is doing my quotient, which is 2m plus 1, plus my remainder, which is 14, and my divisor is 2m minus 1. There's my answer. Okay. Second part of the assignment, they're going to ask you to graph the function. Now, by looking at it right now, you've probably never seen values like this in order to graph it. You probably haven't. But there's a way we can manipulate it into a form that you are familiar with. If you use long division and use the quotient and remainder, it'll look similar to our general equation for radical functions, which is y equals a divided by x minus h plus k, which we learned in 12.2. So first step is to do long division to find the quotient and see if we can graph it. So we got x divided by 2x minus 7. And so here I'm going to find a value which would make, get rid of the 2x, so that'll just be 2. So at 2x minus that cancels out. I drop down, I got negative 7. And I can't do anything with that anymore, because if I put another value in there, that'll leave me with an x, and I can't do anything with it anyway. So my answer for this would be 2 minus, or actually 2 plus, I'm sorry, 2 plus a negative 7 divided by x. Or you can rewrite it like negative 7x plus 2. And that looks a lot like this, where our h is 0 and our k is 2. And so then now you just do the same things that you did when we did section 12.2. So we make a t-table as if we didn't have a k or an h in there at all. So we negative 7, 7, 1, negative 1. And so if we substitute in those x values in for y, we would get 1, negative 1, negative 7, and 7. And so I'm going to plot those points. So I got 7, 1. I got 9, 8, 7, 1. I got 1. So 9, 8, 7. And the last one would be 9, 8, 6. So those would be the plotted points from your t-chart. Now you go back to this original equation, and our h is 0, so there's no horizontal shift, but k is 2, so that means we have a shift up a 2. So I'm going to change the color of my pen, and I'm going to move up 2 units. And that is how we draw our graph. Sorry. All right. Last example. So I got x minus 3, or sorry, 4x plus 2 divided by x minus 3. So if I'm going to put the long division, I got x minus 3. That's what I was trying to say, but skip this step. Divided by 4, x plus 2. And so to find a value that is going to cancel out my 4x, it'll just be 4. So if I distribute that out, it'll be 4x minus 12. And this whole thing gets subtracted. So if I distribute that negative, so I have a negative 4x, and I got a negative 12 plus plus. And this cancels, and 2 plus 12 is 14. So my answer would be 4 plus 14 divided by x minus 3, or y equals 14 over x minus 3 plus 4. And again, your t-chart, 14, negative 14, 1, negative 1. We treat this as if x equaled 14 over x. So we got 1, we got negative 1, we got 14, and we got negative 14. So if, let's just say that each unit here equaled 2. Okay, so I'm going to go 2, 4, 6, 8, 10, 12, 14, and 1 right about there. And 2, 4, 6, 8, 10, 12, 14, negative 1, so it's right about there. 1, and 2, 4, 6, 8, 10, 12, 14, so about there. And negative 1, and then 2, 4, 6, 8, 10, 12, 14. So those are the plotted points if x just equaled 14x. But we have our h here equals 3 and our k here equals 4. So that means that we're going to move it to the right 3 and up 4. So if these are 2 units, so that means it's 1, 2, 3, and then up 4. So 1, 2, 3, 1, 2, 3, 4. So that's right there. 1, 2, 3, 2, 4. 1, 2, 3, 1, 2, 3, 4, and 1, 2, 3, 1, 2, 4. So these red points are going to be my new plotted points. So it'll kind of look something like this and something like that. And so there you have it. And that is how you divide polynomials and also graph the functions. Hope this helps. Till next time.